The Vatnajökull ice cap stretches across southeastern Iceland like a frozen ocean, covering over 8,000 square kilometers of volcanic terrain. Beneath its surface, ancient secrets lie preserved in layers of compacted snow and ice that have accumulated over millennia. In the summer of 2019, a team of glaciologists arrived at the glacier's southern edge to study the accelerating rate of ice melt caused by rising global temperatures. What they discovered would challenge everything they understood about the region's history. Dr. Henrik Larsson, a geological engineer from the Norwegian University of Science and Technology, had spent 2 decades studying glacial formations across Scandinavia. His work focused on how climate change affects ice stability and the release of geological materials trapped within frozen masses. The Vatnajökull expedition was supposed to be routine, a standard survey using ground-penetrating radar to map subsurface structures and assess melt patterns. The team set up their equipment on a relatively flat section of the glacier, approximately 12 kilometers from the nearest research station. On the 3rd day of surveying, the radar equipment detected an anomaly at a depth of 47 meters. The signal reflection pattern was unlike anything typically associated with volcanic rock, ice pockets, or geological formations. It was geometric, precise, and appeared to be metallic in composition. Initial readings suggested a structure roughly 6 meters in length and 2 meters in height, oriented horizontally within the ice. The team conducted multiple passes over the area, adjusting frequencies and calibrating instruments to rule out equipment malfunction. Every scan confirmed the same result. The discovery posed an immediate question. No known human activity had occurred at this depth or in this location during any documented period of history. The ice surrounding the object was estimated to be between 200 and 300 years old based on core samples taken nearby. Whatever lay beneath had been encased long before modern industrial machinery existed in Iceland. The team documented their findings and transmitted preliminary data to their research institution, requesting additional equipment and personnel. Within 5 days, a larger expedition arrived with specialized drilling apparatus designed for precision ice extraction. The operation required extreme caution. Drilling through 47 meters of glacial ice carries significant risk of structural collapse and contamination of whatever lies beneath. The team established a secure perimeter and began the slow process of creating a vertical shaft, using heated coils to melt through the ice rather than mechanical drills that might damage the object below. As they descended through the layers, ice core samples revealed something unexpected. The ice immediately surrounding the anomaly showed thermal disturbance patterns, microscopic fractures that suggested exposure to heat at some point in the distant past. Chemical analysis detected trace amounts of copper and iron oxide dispersed through the ice matrix, elements that do not naturally occur in glacial ice at these concentrations. The deeper they went, the more the evidence pointed toward something artificial, something that had generated heat. On the 11th day, the drill team broke through into a small cavity within the ice. When they lowered a camera probe into the space, the images transmitted to the surface monitors stopped everyone in their tracks. There, suspended in a pocket of frozen air, was a machine. Its surface was dark, corroded but intact, with visible mechanical components including what appeared to be gears, cylindrical chambers, and a series of copper coils wrapped around a central axis. But the most unsettling detail was not its presence or its age. It was the faint rhythmic vibration detected by the probe's sensors. Something inside the machine was still moving. The initial reaction among the team was disbelief. Machines do not function after centuries of frozen isolation. The laws of thermodynamics, material degradation, and energy conservation all argued against what the sensors were reporting. Yet the data remained consistent across multiple readings. A low-frequency vibration, measured at approximately 0.3 Hertz, emanated from within the device. It was slow, deliberate, and continuous. Dr. Larsson ordered an immediate halt to all drilling operations until they could assess the situation more thoroughly. The team consulted with experts in mechanical engineering, archaeology, and historical preservation via satellite communication. No one had a satisfactory explanation. The design of the machine did not match any known technology from the 18th or 19th centuries. The configuration of its components suggested a level of precision manufacturing that seemed anachronistic for the estimated age of the surrounding ice. Some team members proposed that the ice dating might be incorrect, that perhaps the object had been deposited more recently through some unknown means. But subsequent analysis of the ice layers confirmed the original assessment. The machine had been there for at least 200 years. A decision was made to extract the entire object intact rather than attempting to study it in place. The risk of structural collapse within the glacier was increasing as summer temperatures continued to rise. Over the next 6 days, the team carefully expanded the cavity around the machine, using controlled heat application to melt the ice without direct contact. They constructed a support framework of reinforced cables and hydraulic lifts, slowly working the device free from its frozen prison. The operation required extraordinary precision. Any sudden movement or temperature change could potentially damage both the machine and the integrity of the glacier itself. When the object finally emerged into daylight on the 18th day of the expedition, its full form became visible for the first time. The machine was approximately 5.7 meters in length, cylindrical in shape, with a diameter of roughly 1.9 meters. Its exterior casing was constructed from what appeared to be bronze, or a bronze alloy, heavily oxidized but structurally sound. Along its length, a series of viewing ports made from thick glass or crystal allowed glimpses into the interior mechanisms. Through these ports, the team could observe a complex arrangement of gears, wheels, and what looked like a liquid-filled chamber that slowly rotated within the main body of the device. The most extraordinary feature was located at one end of the cylinder. A system of interlocking copper coils surrounded a central shaft that extended into the machine's core. Even in the bright Arctic daylight, a faint luminescence could be detected emanating from within these coils, a pale blue glow that pulsed in sync with the measured vibration. Power meters placed near the device registered a weak electromagnetic field, fluctuating in a regular pattern. The machine was not just moving, it was generating energy, or perhaps converting it from some unknown source. Dr. Larsen's team documented every detail with high-resolution photography and three-dimensional scanning equipment. They took samples of the corrosion, the glass ports, and residual ice that had been in direct contact with the machine's surface. Spectrographic analysis of the metal composition revealed an unusual alloy combination, primarily copper and tin as expected in bronze, but with trace elements including silver, gold, and something the spectrometer could not initially identify. Further analysis suggested the presence of a rare earth element, possibly neodymium, which would not have been available to metallurgists in the 18th century. The liquid visible through the viewing ports presented another mystery. It appeared viscous, darker than water, and moved in a way that suggested higher density. When thermal imaging cameras were directed at the machine, the liquid chamber registered several degrees warmer than the surrounding air temperature. Heat was being generated internally, though the mechanism remained unclear. The team hypothesized several possibilities: residual chemical reactions, radioactive decay of unknown materials, or some form of mechanical perpetual motion that defied conventional physics. None of these explanations felt adequate. As word of the discovery spread through academic channels, theories began to emerge. Some historians suggested it might be an experimental device from the early Industrial Revolution, perhaps transported to Iceland by adventurous inventors and lost in a glacial accident. Others proposed it could be related to early attempts at automation or clockwork engineering, though no historical records mentioned anything remotely similar. A few voices suggested more unconventional origins, pointing to the advanced materials and the impossibility of sustained mechanical operation over such a time span as evidence of something beyond conventional historical understanding. The machine was carefully transported to a climate-controlled facility at the University of Iceland in Reykjavik, where it could be studied in greater detail. Throughout the transport, monitoring equipment confirmed that the vibration never stopped, never varied in frequency, and never showed signs of diminishing. Whatever powered this device had been running continuously for at least 2 centuries, hidden beneath the ice waiting to be found. The research facility at the University of Iceland became the center of an international scientific effort. Experts from disciplines ranging from materials science to theoretical physics arrived in Reykjavik to examine the machine. Security protocols were established to protect the device from damage or tampering, and a rotating schedule of observation teams maintained constant monitoring. The device was placed in a sealed chamber with controlled temperature and humidity, surrounded by an array of sensors measuring everything from electromagnetic radiation to gravitational anomalies. The faint blue glow continued to pulse, and the vibration persisted with mechanical regularity. Initial attempts to understand the machine's construction focused on non-invasive analysis. X-ray imaging revealed an interior far more complex than the external appearance suggested. Nested within the cylindrical housing were multiple layers of gearing systems, each operating at different rotational speeds. The liquid chamber at the core appeared to be divided into segments by thin metallic membranes, creating a series of interconnected cells. As the chamber rotated, the liquid moved between these cells in a carefully orchestrated pattern, suggesting the entire system functioned as both engine and regulator. The copper coils at the end of the device were wound with extraordinary precision, thousands of turns creating an intricate electromagnetic array. Dr. Larsen collaborated with Professor Anya Volkov, a mechanical historian from St. Petersburg State University, to search historical archives for any mention of similar devices. They examined patents, engineering journals, and private manuscripts from the 17th through 19th centuries across Europe and beyond. While they found numerous examples of elaborate clockwork mechanisms, water wheels, and early steam apparatus, nothing matched the sophistication or configuration of the glacial machine. The level of metallurgical knowledge required to create such precise alloys and the understanding of electromagnetic principles necessary to design the coil system both suggested a level of advancement that should not have existed in that era. One particular detail troubled the research team. The viewing ports along the machine's length were made from a crystalline material that analysis identified as synthetic sapphire, aluminum oxide grown in laboratory conditions. The production of synthetic sapphire was not successfully achieved until the late 19th century, and even then creating pieces of this size and clarity would have been extraordinarily difficult. Yet the ice core dating remained consistent. The machine had been frozen into the glacier sometime between 1700 and 1800, decades before synthetic sapphire production became possible. Either the dating methodology was flawed, or the machine incorporated materials from a source not yet understood. Attempts to access the machine's interior were met with unexpected resistance. The device appeared to be seamlessly constructed, with no visible bolts, welds, or access panels. The metal surfaces showed signs of corrosion and age, but no weak points that might allow entry without causing damage. The Research Ethics Committee debated whether invasive investigation should even be attempted. The machine was operating stable and presumably fragile. Any interference could potentially stop the mechanism that had run for centuries, destroying the very phenomenon they sought to understand. A consensus emerged to continue non-invasive study until more information could be gathered. Meanwhile, the electromagnetic field generated by the device became a subject of intense scrutiny. Physicists measured the field strength at various distances and angles, mapping its three-dimensional structure. The field was not uniform, but rather pulsed in complex patterns that seemed to correlate with the internal rotation of the liquid chamber. Spectrum analysis revealed frequencies across a broad range, from extremely low frequency waves measurable in hertz to much higher frequencies in the kilohertz range. Some researchers proposed that the machine might be designed to receive or transmit information through these electromagnetic pulses, though no pattern resembling communication could be identified. Dr. Larsen initiated a parallel investigation into Icelandic historical records, searching for any accounts of unusual events or missing expeditions in the region of Vatnajökull during the 17th and 18th centuries. Glacial archives, while incomplete, did reference several unexplained incidents. In 1763, a survey team reported strange lights visible within the ice near the southern edge of the glacier, lights that moved beneath the surface for 3 consecutive nights before disappearing. In 1812, a local farmer claimed to have heard a deep humming sound emanating from the ice, a sound that persisted for weeks before fading. These accounts, previously dismissed as folklore or natural phenomena, now demanded reconsideration. Chemical analysis of the liquid inside the machine's chamber provided another layer of mystery. Spectroscopic examination through the sapphire ports identified a complex mixture of organic compounds, metallic salts, and suspended particles of an unknown composition. The liquid's color suggested the presence of copper compounds, but its behavior under observation indicated properties unlike any known fluid. It appeared to be both lubricant and energy storage medium, possibly even serving as a coolant for internal processes. The temperature differential between the liquid and the surrounding machinery remained constant at approximately 4.2 degrees Celsius, suggesting active thermal regulation. As months passed, the machine showed no sign of stopping or degrading. Power consumption measurements indicated that if the device was drawing energy from an external source, that source was not electromagnetic radiation, heat differential, or any other conventional energy input they could detect. The possibility that the machine contained an internal power source, something that had sustained operation for 2 centuries without refueling or recharging, challenged fundamental understanding of energy conservation. Some researchers began to whisper about possibilities that sounded more like science fiction than science, theories involving unknown physics or materials with properties not yet discovered by modern technology. The breakthrough came from an unexpected direction. Dr. Eliza Chen, a computational linguist from MIT who had joined the research team out of curiosity, began analyzing the electromagnetic pulse patterns emitted by the machine using algorithms designed for pattern recognition in ancient languages. Her hypothesis was unconventional. If the pulses contained information, they might follow structural rules similar to syntax and grammar. After 3 months of data collection and analysis, her software identified recurring sequences within the electromagnetic emissions, patterns that repeated at intervals ranging from hours to days. The pulses were not random, they were organized, deliberate, and possibly meaningful. The discovery shifted the investigation's focus. If the machine was transmitting information, the next question was whether it was also capable of receiving. Dr. Chen proposed a carefully controlled experiment. Expose the device to specific electromagnetic frequencies and observe whether its behavior changed in response. The ethics committee debated the proposal extensively. Any interaction with the machine carried risk, but the potential to understand its purpose outweighed the concerns. Permission was granted under strict monitoring conditions. The first attempts produced no observable effect. The team transmitted simple pulses across various frequencies, but the machine's operation remained unchanged. Then Dr. Chen adjusted her approach. Instead of arbitrary signals, she used the machine's own pulse patterns, playing them back as a form of echo. Within minutes, the device responded. The vibration frequency increased slightly, from 0.3 Hz to 0.35 Hz. The blue glow intensified, and the liquid chamber's rotation accelerated. The machine had recognized something in the transmission. Over the following weeks, the team developed a primitive communication protocol, sending specific pulse sequences and documenting the machine's responses. The interactions suggested a form of feedback loop, as if the device was designed to synchronize with external signals. Dr. Larson theorized that the machine might be part of a larger system, a component designed to work in conjunction with other devices. If true, the question became, where were the other components? Were they still buried in ice elsewhere, or had they been destroyed, removed, or perhaps never brought to Iceland at all? Historical research took on new urgency. Dr. Volkov discovered a reference in a private collection of 18th century correspondence belonging to a Danish merchant named Frederick Olufsen. In a letter dated March 1779, Olufsen mentioned a commission of great secrecy involving the transport of philosophical instruments of extraordinary nature from Amsterdam to Iceland. The letter provided no further details, but the timing aligned with the estimated period when the machine became encased in ice. Further investigation revealed that Olufsen's ship, the Margareta, disappeared during a voyage to Iceland in late 1779. No wreckage was ever found, and the cargo manifest had been lost to time. The connection was circumstantial but compelling. If the machine had been aboard the Margareta, some catastrophic event must have occurred near Vatnajökull. Perhaps the ship had been transported overland and encountered a sudden glacial collapse, or maybe the device had been deliberately placed within the ice for reasons now impossible to determine. The lack of definitive evidence left room for speculation, but the historical thread provided context that had previously been missing. As the second year of study approached, the research team faced a fundamental dilemma. The machine continued to operate, stable but inscrutable. Despite thousands of hours of observation, advanced materials analysis and attempted communication, its true purpose remained unknown. Was it a navigation device, an astronomical calculator, an early experiment in perpetual motion, or something entirely different? The more they learned, the more questions emerged. The synthetic sapphire, the advanced alloy composition, the self-sustaining energy source, all pointed toward capabilities that seemed impossible for the era in which it was created. Some researchers advocated for more invasive investigation, arguing that understanding the machine's internal mechanisms was worth the risk of potentially stopping its operation. Others insisted that the device should be preserved in its functional state, that destroying what might be a unique artifact of unknown origin would be an irreplaceable loss to science and history. The debate continued without resolution, reflecting deeper questions about how humanity approaches mysteries that challenge established understanding. Dr. Larson, now in his 60s and nearing retirement, spent his final months on the project compiling a comprehensive documentation of every finding, every theory, and every unanswered question. He understood that the mystery might outlive him, that future generations with more advanced technology and different perspectives might succeed where his team had not. In his final report, he wrote that the machine represented something profound about human knowledge and its limits, a reminder that the past might contain achievements and understandings that modernity had forgotten or never known. The machine remains in its climate-controlled chamber at the University of Iceland, still running, still pulsing with that faint blue light, still vibrating with mechanical precision. Observation continues under international oversight, and the data streams outward to research institutions across the world. Every few months, new teams arrive with new ideas, new instruments, new approaches to the same ancient puzzle. The glacier that once held it continues to retreat, revealing other secrets in its melting embrace, but none have captured the imagination, quite like the device that refused to stop. What lies within that bronze cylinder, what knowledge or purpose drove its creation, remains locked behind sapphire windows and corroded metal. Perhaps one day the code will be broken, the mechanism understood, the mystery resolved. Until then, it endures as it has for centuries, patient, persistent, and profoundly inexplicable, a machine from another time that continues to run in ours.